Okay, quantum mechanics. The quantum mechanical model replaced the Bohr model in the early 20th century. It was revolutionary because in the Bohr model, in the quantum mechanical model, electrons are not behaving as particles. The Bohr model had orbits. The quantum mechanical model has orbitals. Now, those words are very similar, but an orbit is like our planet's orbit around the sun. It's a defined course, and you stay on that course, and that's it. An orbital is actually a probability map. It's a region of space in which that electron is likely to be found. In the quantum mechanical model, we cannot picture electrons as like being miniature baseballs or something that are flying through the air. They do not behave like that. Is this something? Yeah. Okay. So let's compare baseballs and electrons. Here we have a picture of a player pitching a ball, and here's the batter wanting to hit the ball. We can predict the path of a baseball that's pitched. That's what enables people to hit the ball, right? Your eye does all sorts of sophisticated calculations and predicts where that ball's going to go. Now, of course, you can alter the trajectory of the ball by doing a curve ball or putting different sorts of spin on the ball. But the baseball's path is predictable. So if you have a baseball pitcher pitching the ball, he's doing his fastball, he's doing it exactly the same every time. The baseball goes exactly the same path every time. We understand that. Electrons are different. Electrons are very, very small. They don't obey the same rules that the rest of regular stuff obeys. Even if you were to throw an electron in exactly the same way, it would land in a different place every time. Is that disturbing? How could that be? It should be disturbing. So this is an illustration of if you took an electron and pitched it in exactly the same way, these little dots are showing where the electron would land. It would not go in the same place every time like a baseball would. Now, you have a higher probability of it landing in the center than you do over here, but the baseball could even go, the electron could even go right through the fence and hit that guy in the nose. Electrons are very unpredictable. Electrons and photons, packets of light energy, exhibit what's called wave-particle duality. They behave like waves and they behave like particles. So this is illustrating a probability map. So we can say, well, 20% of the time it's within this circle, within this larger circle, 40% of the time, 70% of the time it's going to be within this larger circle. The larger the circle gets, the higher the probability that the pitched electron is going to be within that space. So an orbit is like the planetary orbits. It's a circular or elliptical path that's predictable. An orbital is a probability map showing the relative likelihood that an electron is found within that space. It's completely unpredictable. You cannot predict where the electron is. You can predict where the sun's going to be next Tuesday. Not the sun, the Earth. You can predict where the Earth is going to be relative to the sun next Tuesday, because it's following a very predictable path in orbit. An orbital is not predictable.